Okay, so now I'm just going to fly through a quick few examples. So as you can see, we have a right angle triangle here. And as I mentioned earlier on in the video, the first thing you need to find when you're given a right angle triangle is where the right angle is. Okay, so if that's the right angle, we know that this side is across from the right angle, so that automatically makes this the hypotenuse. Now, the opposite and the adjacent all depend on what angle you're talking about. So as you can see here, I have the letter A, so these questions all relate to the letter A and the angle A. The angle A is here, so this side, the 5, is going to be the opposite. And this side here, the 12, is next to the A, so that means that that side is going to be the adjacent. So if we go down to the question, it says, which trigonometric ratios connects 5 and 13? Now, first thing we need to do is, what side is 5? 5 is the opposite. And 13 is the hypotenuse. So if we go back up to our section above, for SOH CAH TAO, our rhyme, which trigonometric ratio, or which trig ratio, just to make it easier, which trig ratio has opposite and hypotenuse together? Now you can see that it's this one, it's sine. So sine of the angle will give opposite over hypotenuse. So if I go back down to here, 5 and 13 is connected by sine, so it's sine A. Now if we look at the second one, it says which connects 12 and 13. 12 is the adjacent and 13 is still the hypotenuse. So again, if we go back up to our phrase, in SOH CAH TAO, which trig ratio connects adjacent and hypotenuse? It is this one, so it's cos. So if we go back down to here, 12 and 13 is connected by cos, so that is going to be cos A. And the last one, we're connecting 5 and 12. 5 is the opposite, 12 is the adjacent, so that means the opposite and adjacent comes from tan, so it's going to be tan A. So that's how the connected sides work. Now, as you can see, I have a B option as well. So I have the other angle. Now, because we're talking about B, we need to focus from this angle. And because we have a different angle, that means we're going to have a different side, which is opposite the angle. So I'm going to get rid of this adjacent and this opposite. The hypotenuse will stay the same, because that's still across from the right angle. The only change is now the side that is opposite B is 12. And the side that is adjacent to B is 5. So now it depends on which angle you're looking from, which will decide what is the opposite and what is the adjacent. So as you can see, that's B. This side is opposite B. So now this changes. So now if I look at my sections, I'm not going to go back up to the trig ratios. I want to see if you can try and remember it. So SOH CAH TAO, or oh hell, another hour of algebra. See if you can remember it from there. So question 1, 5 and 13. Which trig ratio connects 5 and 13? Well, 5 is the adjacent in this case. 13 is still hypotenuse. Adjacent over hypotenuse is cos. So cos B. The second one, we have 12 and 13. In this case, 12 is opposite B and 13 is still hypotenuse. Opposite and hypotenuse is sine. And the final one, 5 and 12. 5 is adjacent. 12 is opposite. We don't have an adjacent and opposite, but we do have opposite and adjacent. And opposite and adjacent is tan B. Okay, this is our second example. Instead of having the angles A and B, I've actually got the angles 30 degrees and 60 degrees. And still we have a right angle, so that's our right angle in the corner. Now this triangle is actually one of the special case triangles. You're going to meet that a lot the whole way through this series of videos on trigonometry. If you want to watch a particular video about the special triangles, then you can click the link above. That will bring you directly to that. But in the meantime, we're just going to work on with this example. So my first example is going to be based on the 60-degree angle. And I want to know, if I said to you, sine of 60 degrees, could you tell me what that value is? Okay, so we know that sine is opposite over hypotenuse. We still haven't found the hypotenuse yet. So the first thing I'm going to do before I do any more maths is find where the hypotenuse is. This is the right angle corner here. This side is across from the right angle. So that means that the 2 is going to be my h, my hypotenuse. Now we're talking about 60 and we're talking about sine. So that means we're in this section here. What side is opposite the 60? It is root 3. So in this case, we're going to have O. So that leaves 1 as the adjacent. So we know that sine is opposite over hypotenuse. So this is the opposite. This is the hypotenuse. So what we're going to do is put the opposite, root 3, over the hypotenuse, which is 2. And if you go to your calculator and type this into the calculator, the answer will come out as root 3 over 2. Okay, so from our phrase above, we know that cos is adjacent over hypotenuse, but it is adjacent relative to 30 degrees. So what I'm going to do, just to make it a little less confusing, I'm going to get rid of the O and H now. Sorry, the O and A. The H will always be the same because that's always across from the right angle. That doesn't change. But we're now talking about 30 degrees. So we need to decide what is the adjacent and what is the hypotenuse. The hypotenuse is the same. This, number 1, is opposite the 30 degrees. So that means that this side is the adjacent. So the second example, I want you to find what is cos of 30. Now you can pause the video here if you want to try it yourself, and then you can see what the answer is. Okay, so now we're talking about 30, which is this angle. I've gotten rid of the O and the A that were here because the sides change depending on what angle you're talking about. Up here we were talking about 60 degrees, which is this angle, but now it mentions 30 degrees, which is this angle. So I'm going to rename my sides. The hypotenuse is still the same because that's always the side across from the right angle. Cos 30, well, if this is 30, that means that this is the opposite and this one is the adjacent. So I'll write down O and A. And now cos 30 is the adjacent, which is root 3, over the hypotenuse, which is 2. So we get root 3 over 2. So one final example I'm going to do is going to be tan of 60 degrees. So we're going to find out what the answer for tan of 60 degrees is. Now tan 60 degrees, so we're talking about this angle here, so that means this side is no longer the adjacent, it is actually going to be the opposite. And this side is going to be the adjacent because we're talking about 60. This side is opposite the 60, so now our O and A change again because we've changed position. So tan is O over A, which is root 3 over 1, which you can just write down as root 3. Okay, so that's the end of this video. Hopefully that has helped you have a better understanding of sine, cos and tan and how to use them when you have right angle triangles.